We're going to see today how you can test the strength of an acid and a base based off of its ability to dissociate, and we're going to test that with a light bulb that's hooked up to an anode and a cathode. What we'll do first is put it in some ammonia, have it covered just because it smells. And when we put it in there, we see that almost nothing happens. We talked about ammonia being a base, and that's the base that made it difficult for Arrhenius's discovery of acids and bases, being a base but not having a hydroxide group. We'll just wash off the electrode here. Don't want any contamination between the different beakers. Our second beaker is a strong base. It is going to dissociate a lot, so we should expect to see a light, and we do. NaOH is a strong base. We'll wash the electrode again. Again, we don't want any contamination, especially now because I'm going to put the electrode into an acid, acetic acid to be specific, which is commonly known as vinegar. And even if we hadn't talked about it in lecture, we would know that it is a weak acid. All of these solutions have the same molarity, so their pH is not going to change based off of that. What it will change on is the fact of the amount that it dissociates. You can have a very, very strong acid, and it could have a lower pH than a very, very concentrated solution of a weak acid. The next one I will place this in is hydrochloric acid. And we hear some sparking, and we've got a nice bright light there. So hydrochloric acid, we know, is going to be a strong acid, very similar to sulfuric acid, which means again that it's just dissociating quite a bit.